So we do pretty much the same thing. For B and C transpose, those things are going to be simpler because we only have a vector. Oh, hold it. Before I leave this, I wanted to ask something. Does anyone see a way we can simplify the function we just coded, this function? Does anybody see something that we can do to simplify it? And will improve the accuracy of the calculations as perhaps a bonus. Is there something we can do to shorten the calculation time and maybe also at the same time improve the accuracy? Is there something maybe that is 0 and therefore should not have been, may not have been included in that expression? Say just what is 0? Huh?
F(I) x naught u naught v naught.
Absolutely. Remember, nominals are defined by setting this equal to 0. You know, went ahead and coded it there. And how do you code it? Well, here's the other thing. Computer calculations are not perfect. And I have found out that you get a little bit more accuracy if you actually code that, because the errors in this tend to be similar to the errors in this. So you have some error cancellation by including it. So I actually purposefully included it, even though we know the exact value is 0. But what I mean is not the correct value of this, I mean it's the correct value of Aij. Because you have some error cancellation between the two, it's best to recalculate it and to come perhaps slightly different than 0, but it results in more accurate Aij. Okay? So that's the point. Would have been too bad if you didn't have it, but you get a little bit more accuracy. Okay. Now let's do B. So I'll put next comment, calculating B vector. Let me do something I just realized I should have done. Let's put some enters here to make things right. So, we'll follow pretty much what we did with A, or calculate, basically. It's a terrible thing to be a perfectionist. No reason to correct this out of perfectionism. Remember the 4 resets the beginning value? So that's why I can freely use i's and j's. So I can directly calculate it. And I don't even have to create, actually let me go back on the board, anything special, because what's the special u? Okay, let's write what is the partial fi with respect to u. So pi, which is the partial of fi with respect to u at nominal steady state, is approximated by fi at the whole x at x naught. There's only one component of u. So that's going to be simply u naught plus delta u. I can put that in the argument directly. I can have a calculation in the argument of the function. So I can put u naught plus du at the argument all that divided by delta u. So in this case, we don't need anything special. We simply call the function first with u naught plus delta u in the argument, and then with the other side. We need to create the u. Same heuristic applies. So we can create a du. Okay, I will declare a du. So, just a single loop. And let's create a du. And as before, let's protect
Is that 7 zeros?
I put D minus 8 or E minus 8. It will automatically put that. Just put 1 D minus 8 or 1 D minus 8. Like here, 1, I put D minus 9, and you see that it will automatically put as many zeros. And now we're ready to calculate the I. So B I component is going to be equal to, open parentheses, f of x, everything nominal, for u nominal plus du. I can put the calculation in the argument. I would have created a u special equals u naught plus du, but instead I put in the argument, comma, d everything nominal, comma I, minus everything nominal, f of x naught, comma u naught, doo, comma I, divided by what? Du. This one here. Say again? Oh, yeah, I need another parenthesis. Thank you, Sean. Yep. I was missing a parenthesis. And then we can output it. And before we put the output, let's go to Excel and figure out where we want to put it. So, how about if we do it right next to A, if we put it right here? Now, if we write a general program, let's figure out where we should be putting it. So I want to put it there. So let's do some thinking where we should put it. I have here logic, and the last A we have A and N will go to N plus 1, N plus 5. So the last column that the A matrix uses is N plus 5. This column is N plus 5. With me? So, this is N plus 6. I want to put in column N plus 7. Andrea, you look a little bit puzzled. You're okay. One okay?
Yeah, isn't B just like one thing?
Has one column, but it has several rows. It's a vector.
Oh yeah, two. True that.
So, we put it here, but I'm writing the program general. Tomorrow I give you a homework in which you have 5 equations. Okay? This program automates everything. So, we wanted to put, so this was N plus 5, N plus 6, N plus 7. The first component should be in second, right? The second component in third. So it's going to be, we want Bij at column sorry, I plus 1 row, n plus 7 row. Sorry, I mixed it up. We want I plus 1 row, n plus 7 row. No, that's fixed. That's the size of the system. If I had 100 variables, I want to be in column 107.
Can you say why is it n again? Why is it n?
Because n is the size of my system. I'm writing a general program that can be used for any number of equations. Right? So the last A I have is A and n. Following that logic, that's going to be in column n plus 5. So A will go until column n plus 5. So this is column n plus 5, the last A column. I want a blank in between, that's n plus 6. So I want to be next, n plus 7. Okay, and the second, that's the column, that's the row. So let's do it. So let's go back here. So we want cells of I plus 1, comma, n plus 7 equals B of I. And we finish this with the next step. Close the loop. If I try to run it, I run into a problem. Why will I run into a problem?
Then define something.
I didn't define du. So let's go. Rim, okay? I need to go back and I want to define du. We totally lost. So I'm going up here, so beginning of subroutine, and need to define here at second line dim du as double. So I need to declare d. Okay? I hope so. I hope out of BI, what did I write? Did I put B sub I?
You put BI.
Oh, should be BI, yes. Yeah. Thank you. Should be BI, there's no J there. Yes. Thank you. Okay. So that's all the code we need for the B vector. I put an extra space to make it more readable. That's a and let's run it. I run from Excel. We can also see the results. So macros, run, and let's. Does that agree with what we found by hand? Okay. Next is the gamma matrix, which I have declared as gamma. So now we're ready to calculate the gamma matrix. Kind of hesitant in doing what I'm going to do next, because some of you may not copy things right, etc., but it will take a lot of time. So please pay attention. Are you all ready to do what I'm doing? Brim, skip B, and let's move on to gamma now. We can do B later. So the easiest way, gamma is a two-dimensional quantity also. So the easiest way to do it is to copy all the lines we wrote for A and adapt them. So the very first thing is I'm going to take my A, calculating A code, and I'm going to be modifying that. So I'm going to copy So when I say calculating A, to next item.
Oh.
Okay? So I'm taking all the A part, I'm putting a control C, and I'm going below the calculate B vector, with some space, control V. And now I'm going to edit things. So the first thing I'm editing is, in the comment, calculating gamma matrix. What's the size of the gamma matrix? It's not n by n.
N by J?
N by R. N is the number of rows. R is the number of columns. So the loop, to get every component of gamma, is going to be I1 to N, but J1 to R. So please, everyone pay attention. Okay, who needs more time? Let me not go fast. Okay. So, first job we did so far. Just copy all the statements that were for the A matrix and put it below the B. That's the first thing we did.
What do you mean below the B?
Huh?
Below the B where?
Below the B. Some are below the B before the end of